So far we have discussed the lecture. So 10 lecture I have given on the basis of the some basic chemistry and organic chemistry in the class 11 lecture, class 11 chapter. Now I am going to the another chapter which is the based on the hydrocarbon. Hydrocarbons. So I divided this lecture in such a way that so in the first in the introduction, but I'll tell you what are the things we'll learn from this chapter. Okay. So then I will go one by one in such a way. Maybe we'll go little bit slowly because this chapter is little bit much more conceptual. So we have to understand in each and every means notable things. So that's why I'll go very slowly in this chapter. So whenever you have any doubt, you can also contact me. So we'll start from the introduction part. So hydrocarbon basically it's actually the hydrocarbon meanings the only the molecule, the organic compounds, all the organic compounds are made from the carbon, hydrogen, nitrogen, oxygen. So mainly the carbon, hydrogen, nitrogen, oxygen, this kind of any organic molecule are made from carbon, nitrogen, or hydrogen, oxygen. So this is called actually hydrocarbon. So how they are classified and how they are given the name according to their structure, according to their arrangement. So this kind of thing we'll learn from this lecture. So in the first things, what I'll go in this way. So I'll go first the introduction part. So in this chapter, the what is the actually introduction here? So introduction is the after starting the unit, after the starting after after finishing this chapter, you will be able to know the name of hydrocarbon according to the IUPAC system of nomenclature. You all know about the what is IUPAC. So according to IUPAC, so we'll give some name to that hydrocarbon moiety and to what are the name and nomenclature come according to them, then we will discuss here. So this is the first we'll discuss name and hydrocarbon according to the IUPAC system of nomenclature. Then recognize recognition of this kind of organic molecule and write structure of isomers of alkane. Recognize and write structure of isomers of alkynes, and aromatic hydrocarbons. So, what are the alkanes? Alkanes mean like a saturated system. Like suppose let's say start from CH2, CH2, and then let's say another CH3. So this is called alkane. Why alkane? Because there is no such thing, no such double bond or triple bond. So whenever you see any structure or any organic molecule where it is no such unsaturated system is there. Unsaturated means already double bond or triple bond or any carbonyl group. If it is present in the molecule, then we can say it is a unsaturated system. Okay, but here it is not possible. So in the case of alkane, so it is if you see any no such double bond is present in the molecule, then it is called the alkane. Let's say for an example, this is a propane molecule. This is called propane. I will go one by one sentence, one by one word. What are the meaning of this word? Whatever I have written here. Let's say this is a propane molecule. So this is called as a alkane. This is called alkane. Okay. Now we'll go to the what is alkene. This is alkane. Okay. Now the second is the alkene. So what is alkene? Alkene is like a so CH and then double bond and then CH2. Okay. So you can see the above structure, there is no such double bond, but here one double bond is present. So whenever one double bond comes, that is saturated by one proton extra. It is here CH2. You can see this is a CH2. Now here it is a CH because one proton, and also here you can see this is a CH3 molecule, but here it is CH2. So that means in the both carbon atom, one hydrogen atom is less from the original structure. So that's why it is called as a alkene because one double bond is present. At least one double bond is present. That means it can say as a alkene. What we can say alkene. Okay. This is called alkene. Alkene, or and other way you can also say olefin. Olefin. Now the another moiety is the alkyne. What is alkynes actually? So alkynes is the, let's say we'll start from here. CH, now triple bond, another CH. This is called alkyne. This is called alkyne. Okay. So this is called alkyne. Why it is called alkyne? Because it is a acetylene moiety. That's why it is called as a alkyne. Okay. So this original name is the original name of this molecule is the acetylene. Original name of this molecule is the acetylene. This is a acetylene moiety. Okay. Now these are all the aliphatic system. Okay. So whenever we come to the aromatic hydrocarbon, aromatic means what? So there will be one ring present in the system. So how it looks like? Aromatic system means, so these three are actually aliphatic system. Now, if we are considering as a aromatic hydrocarbon, so what is the meaning of the aromatic hydrocarbon? So let's say this is a aromatic part. We know the benzene structure in the previous chapter. We have learned what is benzene actual structure. So let's say this is a benzene structure. Okay. So benzene structure means C6H6. So all carbon contain one proton. Okay. All carbon contain one proton. Now you can see one C6H6. This is a C6 and H6. Okay. You can say it is a C6 and H6. This is called benzene ring. Okay. This is called benzene ring. Now, if you go to the, so the first three example, whatever I have given, this is the aliphatic hydrocarbon. Now we are talking about the aromatic hydrocarbon. Now, aromatic hydrocarbon is, let's say, benzene ring. Now learn about various methods of preparation of hydrocarbon. So how we can make this kind of group. Now we understand what is the aliphatic hydrocarbon or aromatic hydrocarbon. Now what are the procedure known for synthesis or preparation of this hydrocarbon? So between distinguish between alkenes, and hydrocarbons on the basis of the physical and chemical properties. So how to distinguish all of them: alkane, alkene, alkyne, and aromatic hydrocarbons. So we can distinguish based on their physical and chemical properties. Okay. So obviously, if alkane and alkene are different because of their chemical properties, even aromatic hydrocarbon also has the different chemical properties. Okay. Now draw and differentiate between various conformation of ethane. So we'll come to, we'll discuss about the ethane. Ethane molecule is the CH3 and CH3. So here also we'll discuss the how many plausible structure conformer is possible for the, like we'll discuss about the Newman projection. We'll discuss about the Newman projection. We'll discuss about the Fisher projection. We'll discuss about the Fisher projection. uh, then also we'll go for the Fisher, Newman. Then we'll go to the Sohor's presentation. Sohor's projection. In this way, we'll discuss about the ethane molecule. Now, appreciate the role of hydrocarbons as a source of energy for the industrial application. Now, let's say we are discussing about hydrocarbon, or what are the applications are there in terms of the industrial process. Okay, so like a source of energy, hydrocarbons are the source of energy, and energy always we need for anything like electricity, any industry we need the energy, source of energy. So these are all from the coming from the hydrocarbon. Okay, now predict the formation of predict predict the formation of predict the formation of the addition products of unsymmetrical alkenes and alkynes on the basis of the electronic mechanism. On the basis of the electronic mechanism. Now predict the formation of the addition product of unsymmetrical alkenes and alkynes on the basis of electronic mechanism. Now comprehend the structure of benzene. explain aromaticity, and understand mechanism of electrophilic substitution reactions of benzene. Now comprehend the structure of benzene, explain aromaticity, and understand mechanism of electrophilic substitution reaction of benzene. Okay. Now predict. This one is already done because I comprehend the structure of the benzene, explain aromaticity, and understand mechanism of electrophilic substitution reaction of benzene. Now predict the influence, directive influence of substituents in monosubstituted monosubstituted benzene ring. Learn about carcinogenicity and toxicity. At the last, we'll talk about the carcinogenicity and toxicity of the hydrocarbon. Okay, toxicity of the hydrocarbon. Now, one by one, we'll go. So, first, we'll go what is hydrocarbon, what are the difference, what is the definition of the hydrocarbon. These are all things we'll discuss here. Now, the term hydrocarbon itself, the term itself, hydrocarbon is self-explanatory, which means compounds of carbon. As I was telling in the first my introduction part, that what is the meaning of the hydrocarbon? Hydrocarbons are made from carbon and hydrogen. Hydrocarbon. So self-explanatory. The term hydrocarbon is self-explanatory, which means compounds of carbon and hydrogen only. Hydrocarbons play a key role in our daily life. You must be familiar with the term of LPG and CNG used as a fuel. So LPG and CNG, we know that they are act as a fuel. So these are all LPG, liquid petroleum gas, and CNG also act as a fuel. So these are all hydrocarbons. So these are all also familiar of the hydrocarbons. Okay. So hydrocarbons means what? So hydrocarbon meanings. So the hydrocarbon means the mates of, which means the compounds of carbon and hydrogen only. Okay. So we know that the hydrocarbon play a key role in our daily life. So you must be familiar with the terms of the LPG. LPG we know. You also know that these are all used for the fuels. Now the LPG. What is LPG? LPG is the abbreviated form of the liquid petroleum gas. Whereas the CNG stand for uh, that means compressed natural gas. So what is the full form? In the exam maybe they will ask you what is the full form of the LPG. So if you see the LPG full form is the LPG. LPG full form is the liquid, uh, liquid, liquefied, liquefied petroleum gas. Okay, liquefied petroleum gas, liquefied petroleum gas. So, so uh, this is the meaning of the LPG, liquefied petroleum gas. Now, the what is the meaning of CNG? So CNG meaning is the CNG full form is the compressed 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 natural gas, compressed natural gas. Now the another term, that is LNG, liquefied. So we know the only about the LPG and CNG. Then what about the another term is also available, that is for the LNG, liquefied natural gas. So what is the meaning of the LNG? So that means liquefied. LNG means L LNG means liquefied natural gas. Liquefied natural liquefied natural gas is also in news in these days. So this is also a fuel and obtained by liquefaction of the natural gas. So how they are making the LPG and CNG, this kind of things. So they are actually making by a, this is all these this is LNG also fuel, LNG. This LNG also fuel. Okay, so this LNG also fuel, and also this is also a fuel, and it is obtained by liquefaction of natural gas, and it is obtained by liquefaction of the natural gas. Now the petrol, diesel, and kerosene oil are obtained by the fractional distillation of petroleum found under the earth crust. Now petrol, diesel, and kerosene oil are obtained by the fractional distillation of the petroleum found under the earth crust. Okay. Now the coal gas is obtained by the destructive distillation of coal. Okay. Obtained. Coal gas is obtained by the destructive distillation of coal, and the natural gas is found in upper strata during the drilling of the oil wells. Okay, so what does means actually the petrol, diesel? So what are the things we use in the bike or bus or any kind of like we are use actually petrol, diesel, and kerosene also we used in the when the time once in a day. So that time, so a long way ago, we don't have electricity. So now then, that time we used actually kerosene oil for the lighting purpose, for the lighting in the night system, for studying any uh, anything. So kerosene oil are obtained by the fractional distillation of the petroleum found under the earth crust. So earth crust, we have a lot of petroleum. So but these petroleums are not in a good shape for the fuel purpose. So what we have to do? We have to distill it out. Distill it out. So what are the kind of thing? The industrial process I cannot show, but the actual imagination, if you want to imagine how they are distilling out, so I can tell you, let's say petroleum. So boiling point, let's say petroleum boiling point is, let's say something around 250 or let's say 1000 degree. Let's say 1000 degree Celsius is the boiling point of the petroleum. Okay. Now let's say I have a shape, I have a RB, I have a round bottom flask, or I have a round bottom flask or any RB which is connected to a to which is connected to a this kind of reflux condenser. Okay, so reflux condenser, and then so there water circulation is also going. So this is the burner. This is, let's say, one heating bar. Okay, this is a heating bar. This is, let's say, RB. This is, let's say, one RB or container where the petroleum is filled up with this much. Okay, now here let's say this is a heating metal. This is a heating metal. Now you are around heating it up to, let's say, 1000. Let's say 1000 degrees Celsius. Let's say heating temperature is 1000 degrees Celsius, and we know the heating temperature of the boiling point of the petroleum is the 1000. Okay, now we are also heating in the same temperature. Now petroleum is here. Let's say here is the petroleum. Okay, here petroleum is here. Now here is the water circulation. Why? So in the boiling point means what? This is, let's say, one liquid. So liquid in their boiling point they will get vaporized, right? So this is a container where we are collecting out. We are collecting out the purified petroleum. Okay, we are collecting the purified petroleum here. We are collecting the is coming from the in this way. Okay, so it will go up to here. Now it has to cross this barrier to comes out here, right? So then we need, actually this is a gas. So in the 1000 degrees Celsius, it is converting to a gas vapor. So the gas vapor, the moment it will comes with the cold water circulation. So here is a cold water circulation is going in between. Okay, in between another small pipe is there. So in this way, it is coming out. But the outside, this is like a closed system. Eh? So the it is coming via in this way. So now let's say it is going in this way. So the vapor is going here, and now upon the here actually water circulation is good. Here water circulation going, here. So this is a cold water, let's say, outside. So now this pipe, inside this pipe, the water circulation is going. So it is coming, and in this way. So once it is going to the vapor, then the moment it will come to the water will touch to this line, then it will again convert to the liquid. So then it will go in this way. It will go and comes out from here because this is the above part. Okay, so let's say this will be little bit above and this will be little bit down. So liquid always go from the up to down, right? So down to up, it is irreversible process. Means it is not possible for a liquid. Liquid always flow from the up to down. So this is in the above. This is the distance. The distance between this one and this one. This will be little bit below, and this is be this will be actually little bit up, so that the whatever circulation is going from this side to this side, so it is coming by this inner hole, then it is coming in out here. Now the moment it will get finished, then you have a purified petroleum here. Now this petroleum, they are collecting in a large amount in the industrial scale. Let's say they are collecting in a ton or liter, 1,000 liter, 500 liter, like in this way. They are distillating out in this way, but I am showing the only the small version of the distillation part, so that you can imagine that how the distillation going. Okay, so first they are collecting from the earth crust. Okay, first they are collecting from the earth crust, then this petroleum, whatever petroleum they are getting, so this is not actually pure, so you cannot directly use in a in your motorbike cycles or all these things. So wherever we need petrol or diesel or kerosene oil, so you cannot use the direct petroleum. So first of all, you have to do the fractional distillation. So what is fractional distillation? So the one container will be up and the another container will be down. So always liquid flow from the up to down, not from the reverse way. The down to up is not possible. So for that purpose, we have to take the distance between this one. It will be little bit high compared to this one. So the moment you will heat it up above 1,000 degrees Celsius or above the boiling point, then it will get evaporate. Then it will start to evaporate all the petroleum. So then once it will comes to the touch of the cold water, then it will again convert it to the liquid form. Now the liquid can go directly from the up to down. So here another container is there where they are collecting the purified liquid, or in terms of the purified petroleum in this way. So natural gas is found in upper strata during the drilling of oil. So where we can get this kind of natural gas. So natural gas is also found in the upper strata during the drilling of the oil. Okay. Now the next thing is the gas after compression is known as the, so after compression is known as the moment you will get the gas. So it is not the compression. The after you compress this gas, then only it will be act like a compressed natural gas. And LPG is used as a domestic fuel with the least pollution. So LPG whenever we need, so LPG after fuel, so it actually used for the fuel purpose. So if it is used for the fuel purpose, then only it will give the least pollution. And kerosene oil is also used in village areas. In general, village areas people are using kerosene oil in the night time. Okay, because most of the village nowadays, most of the villages also they already covered with the electricity. But wherever the electricity is not there, people are actually using for the fuel purpose as a kerosene oil, because kerosene oil is little bit more cheaper compared to the petrol, diesel, all these things. Okay, kerosene oil is also used as a domestic fuel, but it causes more some pollution. And the automobile, and if you're talking about the automobiles actually needs fuels like a petrol, diesel. Automobiles needs petrol, diesel, and CNG operated automobiles cause less pollution. CNG also petrol and CNG. So where we need actually, the LPG also used as a domestic fuel, and the CNG is used in the automobile. So in exam, people can ask you where the LPG is used and where the CNG is using. So LPG is used in the least pollution area or zone, and for the used as a domestic fuel, and automobile kerosene oil is also used as a domestic fuel, but it causes some pollution, and automobiles need fuels like petrol, diesel, and CNG. And the petrol and CNG operated petrol and CNG operated automobiles causes less pollution. All these fuels contain mixture of hydrocarbons. So petrol and CNG operated automobiles causes less pollution, but all these fuels contain mixture of hydrocarbon, which are source of the energy. So when they are using for the fuel purpose, so main criteria for the source of the energy. So this is coming from the hydrocarbon only. So LPG, CNG, all are hydrocarbons only. So these are all source of energy. So hydrocarbons are also used for the manufacture of polymers. So hydrocarbons are also used for the manufacture of the polymers like polythene, polypropylene, and polystyrene. Hydrocarbons are also used for the manufacture of the polymers like polythene, and polypropylene and polystyrene, etc. Now, the which are sources of energy. Now, hydrocarbons are also used for the manufacture of polymers like polythene, polypropylene, and polystyrene, etc. So, higher hydrocarbons are used as a solvents for paints. So the normal hydrocarbons, like the smaller chain hydrocarbons, are used for the something different case. But there's a higher hydrocarbon, let's say more than 100, more than 10, or more than 200, 500 hydrocarbon chains are used as a solvent for paints. So they are also used as a starting material. They are also used as a starting material for manufacture of many dyes and drugs. So in industry or whatever drugs molecules. So let's say the different kinds of. So let's say for an example, HIV drugs and cancer patients drugs molecule. So these are all drugs molecule. So let's say some of the drugs molecule also made by the hydrocarbons, and they are also the starting material of the or starting material. Starting material means what? So let's say you have a target molecule. So let's say you have a target molecule. So you have to achieve this molecule. Now you have to start from somewhere, right? So you have to, let's say you are starting from A. Okay. So if A is the hydrocarbon, so A is the hydrocarbon. So you are starting from here. So that's why it is called as a hydro starting material. So if you start from which molecule, it will called as a starting material. ASAM. That means starting material. ASAM means starting material. Okay. Starting material for the manufacture of many dyes and drugs. Thus, you can well understand the importance of hydrocarbons in your daily life. So, thus you can understand the importance of your hydrocarbons in your daily life. In this unit, you will learn more about the hydrocarbon. So, hydrocarbon, you will learn more about the hydrocarbon moiety. Higher hydrocarbons are used as a solvents for paints. They are also used as a starting materials for manufacture of many dyes and drugs. Thus, you can well understand the importance of the. Thus, you can will understand the importance of hydrocarbons in your daily life. In this unit, you will learn more about the hydrocarbons. Now, let's say we'll go to the next, the classification of the hydrocarbons. Now, hydrocarbons can be classified. Hydrocarbons are different types. How hydrocarbons are different types. So, depending upon the types of carbon-carbon bonds present, they can be classified into three main categories. Okay, in the previous slide only I was talking about the how they are differentiated or how they are classified in a different categories. So one is the saturated, one is the unsaturated, and another one is the last one is the aromatic hydrocarbon. So you can see the classified into they can be classified into three main categories. So one is the saturated, and the second one is the unsaturated, and the third one is the aromatic hydrocarbon. So saturated hydrocarbon contain carbon-carbon and carbon-hydrogen single bonds. If different carbon atoms are joined together, to form open chain of carbon atom with single bond, they are termed as a alkane. As you have already studied in Unit 8, on the other hand, if carbon atom from a closed system or closed ring, they are termed as cycloalkane, and unsaturated hydrocarbon contain carbon carbon multiple bond, double bond, triple bond, or both. So how they are making? So let's say one carbon, another carbon, another carbon. So they are actually joined by a single bond, right? One single bond. So then they are called as a, if they are if they are joined with this kind of double bond, then actually they can double bond or triple bond or alkyne. So this is called alkyne and this is called alkene or alkyne. Now the unsaturated system. So unsaturated system. So these two are unsaturated system. Either they will join with the single double bond or triple bond. If it is a double bond, then it is alkene. If it is a triple bond, then it is a alkyne moiety. Okay. So now let's say if it is not the open chain. So these are all the open chain, right? The moment they will the moment they will closed chain or ring, that time they can term as a cycloalkane if they are connecting with the only single bond. Now let's say if we draw in this way, C, C, and C, right? Now 3C is there. All are single bond, but they are is a closed chain, not the open chain or a ring. One what kind of ring? One three-membered ring. Now then that time they can term as a cycloalkane. So we have done the saturated system is the alkane. Alkane may be the open chain alkane, aliphatic alkane, or the cycloalkanes when they are closed in a closed chain or in a ring system, and they are joined by a single bond. That time they can term as a alkane. And when they are joined by the multiple bond like a double bond, triple bond, then or both double bond, triple bond in a same molecule. That time also they are called as a unsaturated bond. So saturated is the alkane, cycloalkane, or normal alkane. That these are all belonging to the familiar with the saturated family, and the unsaturated family is the one double bond or one triple bond or both double bond and triple bond. Then they can say these are all unsaturated system. And what about the aromatic hydrocarbon? So aromatic hydrocarbons is the, now let's say aromatic hydrocarbon. Now if we draw the aromatic hydrocarbon is the like this, like I said benzene ring. If we draw the benzene ring in this way, let's say this is a benzene ring. Now this is a CH. This is also CH. This is also CH. Here another CH, and this carbon also contain another CH, and this is also CH. So now you can see there is a C6 and H6. This is called as a benzene. Now let's say benzene ring contain one CH3 molecule. This is a benzene ring. Now it contains, let's say, one CH3 molecule. CH3 molecule. Now it can say toluene. This is called toluene. This is called toluene. Okay. Now let's say we have a nitrobenzene. Nitro group present in the benzene ring. Then we can say nitrobenzene. If it is nitrobenzene is present here, then it can say nitrobenzene. This is called nitrobenzene. So these are all hydrocarbons which is familiar with the aromatic hydrocarbon. So this is called as a aromatic hydrocarbon. But nitrobenzene you cannot say aromatic hydrocarbon. So you can say the CH. So this is the normal CH3. So now you bring one CH2 and another CH3. So now this is the ethyl benzene. Okay. So you can say the ethyl benzene, not nitrobenzene, ethyl benzene. So this is like a ethyl benzene. So this is actually looks like a, so ethyl benzene it is actually looks like a hydrocarbon. So total three types of category we can divide it in a, one is the saturated, the second one is the unsaturated, and the third one is the aromatic hydrocarbon. So in the saturated system, it is only familiar with the alkane system, that may be a open chain alkane or maybe a closed system. In the unsaturated system, there is a two possibility. One is the normal alkene that is only connected by one only double bond. If it is connected with triple bond, then it can say alkyne. It may be possible. It is also possible that in one structure, one double bond, one triple bond is also possible. That time we can say the hmm, unsaturated system. And a third one is the aromatic hydrocarbon. That is like a toluene, normal benzene, ethyl benzene, uh, coumarin, and not coumarin. So these are all can be called as a aromatic hydrocarbon. Now, let's say aromatic hydrocarbon to now if you are the special type of cyclocompound. Aromatic hydrocarbons are a special kinds of hydrocarbons, right? Aromatic hydrocarbons are a special types of cyclic compound. So you can construct a large number of molecules or both type open chain and closed chain, keeping in mind that the carbon is tetravalent and hydrogen is monovalent. Okay, alkanes. Now we go to the more depth on the alkene part. As already I mentioned that alkanes are saturated open chain and the hydrocarbons containing carbon-carbon single bond. Methane is the first member of this family. So there will be one the smallest molecule, the smallest molecule which is belongs to the which is belongs to this family, that is a alkane. Now as already mentioned, alkanes are saturated open chain. Alkanes are saturated open chain hydrocarbons containing carbon-carbon single bond. So methane is the first member of this family. Now you can see the structure of methane. So let's say this is a methane molecule. So this is like a so CH4. We know that CH4 is like okay. First, let me draw the structure. This is a carbon is a tetravalent, right? Carbon is tetravalent. CH4 and tetravalent and sp3 hybridized. I know I already told you how to make the how to find the hybridization. So let's say carbon is a 4, outer cell electron 4, and the 4 sigma bond is also present. So 4 plus 4 divided by 2, that means 4. 4 means if it is 4, then it will be sp3. So this is a sp3 hybridized. Okay. Now this is a carbon is tetravalent, hydrogen is monovalent. Now the orbital MO structure. Now if you see the MO of this molecular orbital picture of the CH4 molecule, this is the CH4 molecule. In this junction, this is a overlapping is there. So this is the junction, this is the bond overlapping is there. So that means this is a bond formation is there. So this is called, so it's like a this kind of pyramidal structure. The bond angle is 109. 109 Okay. So as already mentioned, alkanes are saturated open chain, and the CH4 is the molecule which is the first member of this family. Now we'll go to the different topics, a different part, that is the methane gas. So now CH4 is the methane. We know that by is it solid, liquid, or gas? So actually, it is a gas molecule. Methane is a gas found in coal mines. Coal mines, you know, right? Coal mines and marshy places. And if you replace one of the hydrogen atom of methane by carbon and join the required number of hydrogen to satisfy the tetravalency of the other carbon atom, what you get? You get the C2AC. So let's say draw the structure. So let's say we have the CH4 molecule. Now what I am doing? So one of the hydrogen is replaced by another carbon, and we have to satisfy the tetravalence. Let's draw this one. For CH, CCH will be fixed, right? Constant. Now my another hydrogen will replace by another carbon atom. This is a carbon atom. Now let's say this is another hydrogen is present here, and this is also hydrogen is present here. Now another hydrogen. Now what you will get C2H6. Okay. So this hydrocarbon with molecular formula C2H6 is known as the. Now if we see this, thus you can consider C2H6 as derived from CH4 by replacing one hydrogen atom by CH3 group. Go on constructing alkanes by doing this theoretical exercise, that is replacing hydrogen atom by CH3 group. The next molecule will be C3H8. Let's draw this one first. The another hydrogen with carbon molecule. Let's say C hydrogen. So these are all, if you practice it, you'll be expertise on this molecule, this kind of system. So let's say now this two hydrogen is fixed. Now I am replacing this hydrogen with the another carbon. C hydrogen, hydrogen, and another hydrogen. Now what you are getting? H3, 336 and 28. So total C3H8. Now let's say you are replacing another hydrogen, the last hydrogen with another carbon. Now what will be total carbon will be C. Now first you write the four carbon. Now you fill their tetravalency. So this carbon is joined with the one carbon. So that means that this carbon needs three hydrogen. Okay. So this carbon needs three hydrogen. First you put this three hydrogen. So now this middle carbon is joined by two carbon. So that means they need two hydrogen. Okay. They need actually two hydrogen. Now another two hydrogen. Now here also another three hydrogen. Now what we will get? So C4 hydrogen count is 3, is 6, and 4, 10. So total you what? How much you are getting? C4 H10. So first CH4, CH4 to C2H6, C2H6 to C3H8, then C4H10. In this way you can increase your length. So by this way, these all are from the alkane family. These are all alkane family. So these hydrocarbons are inert under normal condition, as they do not react with acids, base, and other reagents. Why? So because these molecule are only made by the carbon and hydrogen, right? So that's why they are not that much reactive or inert. Inert means they are already stable enough. So no one can disturb them until unless you have the some kind of affinity. Then only you can react with this kind of hydrocarbon. So in general, this hydrocarbon bond breaking is not possible, because not possible. I cannot say it is possible. You need a harsh condition. You have to go to the on a high temperature to remove one of the hydrogen from them. So these hydrocarbons are inert under normal condition, as they do not react with acids, bases, and other reagents, and hence they are actually known. They are they were earlier known as the paraffins. In Latin, it is called as a parum. Little means, and the little or the affinity means the affinity, little affinity. Okay, so that means they have the very less affinity towards anybody, and anything. So can you think of the general formula of the alkane family or homologous series? So see them. So if you see that carefully, so C3H8 means the CnH2n plus 2. Now you fixed it. Let's say CnH2n plus 2. C2H6 or C2H6. So now you can see the general formula will be CnH2n plus. So this is the general formula of the alkane moiety. Now, so let's say for an example C2H6. So C2 we know that C2. Now we have to go to C2, C and hydrogen. How many hydrogen will be there? So 2 into 2, 4 plus 2. Total will be 6. Right? Total will be 6. Now let's say we'll go to the another molecule, that is the C3 molecule. Now let's say you count C3 and how many hydrogen will be present? So 3 into 2 means 6 plus 2 means H8. So these are all alkane moiety. Now you go to the C4 system. Let's check C4, and hydrogen is how much? 4 into 2, that means 8. 8 plus 2, that means 10. So that is Cn and H12 plus 2. So that is C4H10. So now we have a C4H10 and C3H8 and C2. Okay. Now can you think of the general formula for alkane family for homologous series? So this is the homologous series of the general formula for the alkane is the CnH2n plus 2. CnH2n plus 2. Now, if we examine the different, if we examine the formula of the different, so you can see this is CnH2n plus 2. So if we found that, if we find that the we find that the general formula, we find that the general formula for alkanes is the CnH2n plus 2. It represents any particular homolog where n is given appropriate value. And can you recall the structure of the methane according to the Vesper theory? Means VSEPR theory, the unit 4. Methane has a tetrahedral structure in which carbon atom lies at the center, and the hydrogen atom lies at the four corner of the regular tetrahedron, and the bond angle is, so I have written there. So it is also written 109.5. So the hydrogen atom will be, the bond angle will be ACH. Means let's say you have this molecule. This is the methane molecule. Now, so let's say this is the ethane molecule, HCH. So this bond angle will be how much? 109, 109.5. So if we examine the formula of the different alkanes, now we find that the general formula for alkane is the CnH2n plus 2. So particular homolog when n is different, then n is given is the appropriate value. Given appropriate value. Can you recall the structure of methane according to the Vesper theory? According to Vesper theory, unit 4, and the methane has a tetrahedral structure in which carbon atom lies, at the center, and the four hydrogen atom lie at the four corners of the regular carbon center. All HCH bond angles are of 109.5. Okay, so maybe then the next week we'll start from here. We can start the alkane tetrahedral family and all these things. So sigma bond, pi bond, and how the overlapping is going. I will show you. I will show you everything in the next lecture, and maybe you can see here the structure of I have taken from the your textbook only, the structure of methane, how it is looks like a pure tetrahedral structure. Okay, the carbon is in the center, and the four hydrogen are at the corner side, and the four sigma bonds, CH sigma bonds are present head-on overlapping. You can see this is called the head-on overlapping. This system is called the head-on overlapping. This is the head-on overlapping. This is called overlap. By this, the 1s orbital of the hydrogen and three sp3 hybrid orbital of the carbon. So this is the sp3. This orbital is the sp3, and this orbital is the 1s orbital. In this way, they are forming the bonds. You have already read that the carbon and the carbon CH carbon sorry the CH sigma bonds are formed by head-on overlapping of sp3 hybrid orbitals of carbon and 1s orbital of hydrogen atoms. Okay. Okay, thank you. Maybe the next